Hello and welcome to this presentation about encapsulation, which is part of using object-oriented programming. The intended audience for this presentation is Year 11 computing students in VCE and Unit 3 and 4 students doing software development. It's probably mostly directed at the 3 and 4 students because it is on the study design and it is likely to turn up in the exam in some form or another. So, our learning intention is that students can explain what encapsulation means, which I think is pretty straightforward. In particular, private, protected and public. I think that's less straightforward, but let's jump in and learn about it. So what encapsulation means is that when you put things in a class, you can control the way that the rest of the program in the world can interact with particular things that you put in this class. So in this picture here, which I don't love, but it is what it is, then there's only one way into the box and the rest of this little ecosystem is protected because it's regulating the access to it. So let me just, it restricts access to some of an object's components. It combines the data, so that's which we call the attributes in this context, and the methods, the behaviors, which are like functions, but we call them methods when they're in a class, into a single protective unit. So they're all protected in the box. It controls access to the data, who can see it and who can write to it, and it prevents unauthorized external modification of internal data and unauthorized access to the methods within. So there are three basic flavors. So the first is public. That's the default setting. If you just create a method, if you just create an attribute, then the default setting is that that is public and it can be accessed from anywhere within the program, including something externally dealing with the program. So that's our default setting, and that doesn't really offer us anything new. Protected is the next level up of protection, and it says I can access this and any of my children can access this. So that comes back to that idea of inheritance that I talked about in another video. So yourself, whether you're a parent, you've got to be a parent, but whether your children can also access it. And then you've got private, and what private means is that only I can access this. So if you've got a variable in there or an attribute and you can see the name of it, some other part of the program can't just call it by that name and say, hey, tell me what the value of that is, or change the value of that. That changing would have to be happening from within the class. Likewise, up on protected, that attempt to read or change it would have to be happening from within either the class or the children of that class. Which is why, actually we'll go back to that in a minute, there's this very useful idea of actually not allowing people to have access. You can technically do it. You can put it in there and say, yep, people can make changes to this, but is to set up particular methods called getters and setters. And a getter is a public method that you can access from outside of the class, and you can say, hey, you're allowed to get this and I'll go and get the data for you. So you're not actually accessing it directly. Its job is to say, yep, I'll go and do that job for you. And likewise, you can be a setter and say, okay, I'll do the job of modifying it if it needs modifying. So you've still got tighter control over it there. Now, coming back to this in Python, man, this stuff a doozy when you see the code. I've only given you this one example because they're all quite different to one another. So up here, we have a private. Now, we remember that a private can only be viewed in this class. So we're creating the class of electronic device, and the two underscores there are what denote that as being private. So that bit there can only be accessed by electronic device. Down here, this one, perform diagnostic, that is protected, and that's denoted by a single underscore. And this one under here, which has no underscores, is public. So I don't know that I would necessarily remember that, but here we have a class of smartphone, which is a child class or a subclass of electronic device. And so it, just going through, Yes, it would be able to access the public because anybody can. And yes, it would be able to access the protected, but it would not be able to access this one here because the private is restricted to just that class itself. As I said, it's a bit of a doozy. Okay, so how does it work in the different languages? Well, the short version is go and look it up. In Python, default behavior needs no prefix. And in fact, that is true in JavaScript as well. If you just give it a name, it's called self in Python and this in JavaScript, and the public keyword over here. So the sort of default in 2 of the 3 is, yep, I understand that this is private. Oh, sorry, this is public. You'll notice that the PHP, the way it's implemented with the keywords, is actually much closer to what the theory of it is in general. Both the Python and the JavaScript, I think, are a little bit, I'm trying to, idiosyncratic, I think is the word I'm looking for. So when it's protected, which is the next level of protection, you've got a single underscore, you've got a single underscore, and you've got the word protected. So far, so good. Private, double underscore in Python, and a hash in JavaScript, and the word private in PHP. There is also some complexity in here about, I think, where Python actually genuinely defends something as not being able to access from somewhere else. It's one of protected or private, but that's where my head started to spin a bit. So when in doubt, look it up. Don't assume that protected always actually is enforced for protected. Sometimes it's just a convention of saying, and in actual fact, both of these seem to say that they're just conventions. So I would be looking it up. All right, let's have a look at our questions. I'm just going to pause for a tick to sort them out, and I'll see you in a second. All right, let's get back into it so we can just concentrate on one question at a time. Access modifiers, public, private, and protected, are only used to control the visibility of data attributes and not methods. Well, that's false. Because one of the beautiful things about them is you've actually got this protective layer around both of those things when you're using these attributes or these access modifiers. Encapsulation helps achieve data hiding by ensuring that an object's internal state can only be changed through a controlled public interface. That's actually true. Let me just check over here on my other screen that I am actually looking at what's true. Yeah, that is true. Yep. So, next one. In a well-encapsulated class, it is considered best practice to make all attributes public. No, that's absolutely false. So, there's those 3, and I realise that I've got these horribly out of order, but you'll cope. So, our next question is that the primary goal of encapsulation is to increase the execution speed and performance of software application. No, it's got nothing to do with it. An attribute marked as private is generally hidden from other classes and can only be accessed within the class where it's defined. Well, that is true. Private means just me. And protected access modifier is typically used to allow a class and its subclasses to access specific members. And that's true. Yep. So private is the highest level of security, then protected, and then public is some security. So that's the end of this. I hope that that was useful to you, and good luck understanding OOP generally.